Cozzini Bros is a knife sharpening company for restaurants and caterers. Delivery drivers drop off freshly sharpened knives across the country. Rachel's dad introduced us to the firm and their issue with driving logistics. He explained that they needed to create a linear programming model to help their drivers find a more efficient route for their deliveries. For the sake of our project, we will focus on minimizing the delivery route times for drivers in the Atlanta metro area, which as a result will lower the cost of wages and the total cost of labor. I'll now pass it over to Josh, who will explain our model.
So the first homepage presents two buttons. One is for if you are a driver, and one is if you are a restaurant. If you click the driver button, it will then pull up a link to our driver questionnaire. The driver then fills this out. The next button does the same thing and pulls you over to a restaurant survey. Here you input the restaurant name, the restaurant longitude and latitude, and the preferred delivery day. At the end of each week, on Sunday night, the Cozzini Bros employee will download the responses from that survey onto a CSV and input it onto this tab. This is for the driver tab. And as you can see, here are the driver's names. Here's what day of the week do they work, which is correlated to an employee type, A for Monday, B for Tuesday, and so on. And here's their latitude and longitude, and here it is split up. The restaurant survey, this CSV will be downloaded into here. And you can see we have all the restaurant names on the left, as well as their latitude and longitude split up, their preferred delivery day, and how many there are on each day of the week. So as you can see, on the delivery days for Monday, it goes here, and you can count that there are 20 restaurants that prefer the delivery on Monday and 16 that prefer the delivery on Tuesday. So we then create a matrix, a giant distance matrix. Here you can see that on Monday with driver A, which is correlated to the drivers right here. So this driver in the instance would be Ryan. We then see that from Ryan's latitude and longitude, we have a distance from all these different locations throughout the entire matrix. So for the 20 locations that prefer the delivery on Monday, we then calculate or give them all index number and calculate their travel distance to minimize that and the time, which is minimized through the minimized route. Here we say that it's 0.35 of an hour, which is about 21 minutes for unloading and reloading in between stops, and the average mile per hour between 2 points is 20. For the sake of time, because our solver takes a couple of minutes to run, we have already completed the solver, and these are the distances and travel times that we get from minimizing our routes on each day. As you can see on Monday, it starts with going to restaurant 3, which correlates up here to Whiskey Bird. And then it goes to 18, 14, and you can pair up and get the route from here. So once you click that, we take this box over here and take this data and put it in our cost analysis. Once we're in our cost analysis, you can see we have the driver, the type they are, the day they work on, their hourly wage, the overtime multiplier, and then this is where our hours worked from the previous sheet comes into play. We then use a couple of formulas to calculate their standard pay, overtime pay, total pay, to finally amass a minimized driver weekly rate wage utilizing the minimized time taken for their route. Briefly looking at the solver code, we can go into our macros, look at our master solver, and here's where you can see the Monday solver. It resets, you set the objective, and here are constraints that is restaurants 1 through 20, and make sure that's all different restaurants, and then the solver solves. And we repeat this for Monday, Tuesday, Wednesday, Thursday, all the way down to Friday.
Thanks, Josh. Our team made multiple assumptions to help simplify our problem when building the model. All of these assumptions can, however, be changed to the specific organization's values. Some limitations of the model include that we calculated the straight line distances between 2 locations, but travel time between 2 straight line distances varies by what roads you take from point A to point B. In the future, if we had more time, we'd want to be able to account for specific streets for the routes to be better customized for the delivery and the schedule. Our model can be used repeatedly for businesses that deliver any sort of good or service for optimizing their delivery routes. We feel strongly that this tool can help organizations cut down on costs and improve efficiency of their delivery activities in the future.